Yeah, hi everyone. Welcome to the this week 10 live session of the CP. Today we will discuss this graded programming assignments of the week 10, and we'll also explain the week 11 programming assignments problem statement. Okay, so yes, Arnath, you there?
Yeah. Can you hear me, right?
Yeah. Okay,
Yeah.
hear you.
Let
Yeah,
me
you can.
actually share my screen. So hopefully the screen is visible. So let me start the explanation. So week 10 programming assignment says that imagine you're in a magical world and you suddenly see a jackpot. You're excited and see that the pot is empty, but there are set of rules, and if you follow them, you can get gold coins instead of copper coins. So this is where the problem statement. So we have a pot, and we actually can get some gold coins if we put some copper coins into it. So imagine we have some copper coins with us, and somehow we have to able to get n gold coins from it. So this is what our constraint is. So we have to get somehow n gold coins, and the setup of this pot goes like this. So there are three rules which we must remember about the jackpot in order to get the gold coins. If we place one copper coin in the pot, then we'll get one gold coin out. If we place four copper coins inside the pot, then the pot will take note of how many gold coins it has tossed so far. So what it does is, so if we place four copper coins inside the pot, it will just take note of how many gold coins till now it's spitted. And if we again place two copper coins inside the pot, then the pot will toss out as many gold coins as it noted. So in the second step, basically the number of coins was noted, that it will actually pop me off when I place two copper coins. So somehow we have to get the minimum number of copper coins that can be spent to get exactly n gold coins. So this is our target. So immediately we could see that as we have many cases to get the minimum value, one way is to actually search it exhaustively, which can, say take 2 power n. Else we have to do it in a dynamic programming way. So that's what the question is. So now we'll just see the inputs and constraints. So the first line will be the number of test cases t, and the next t lines will have integers which represent the number of gold coins that I have to take out. And we have to get the minimum number of copper coins needed to get all the n gold coins. So the constraints are very clear. It's the test cases will be 0 to 50, and L will be always like the number of gold coins will be always 10 to the power 4, the maximum. So let's see the case for the sample input. We have 2, 5, 20. So 2 is like, say the number of test cases. 5 is the first. So we have to take some of the first, the 5 gold coins with so how many minimum copper coins we would be needed. That's the first thing. So in the case when that is only, say we have to somehow put 5 copper coins to get 5 gold coins. This is like, that's the rule. We can't, we cannot have a very good solution better than 5. So, but in the case 2, where we have to get out 20 gold coins, we can only put 15 and get 20 out. Let's see how it is possible. So for the case 2, first 5 copper coins we will put in, and we'll get 5 gold coins back. Now we'll register this 5 say gold coins by adding 4 more copper coins. So suppose say 5 plus 4, which is equal to 9. So we have spent 9 copper coins. Still we have only 5 gold coins with us. So till now the case has not improved. But if I put 2 more coins, 2 more copper coins, then I'll be getting 5 plus 5, which is 10 gold coins in total. And again, if I put 2 more copper coins, so I have spent till now 11. And from 11, if I'm moving to 13, 2 more copper coins, then I'll be getting 10 plus 5, 15, because that was being noted out, 15. And then say again, I have put 2 more copper coins, then I'll be getting 20 gold coins in total. So in total, we have 5 plus 4 plus 2 plus 2 plus 2, which is actually 15 copper coins I have spent, but I got 20 gold coins. So let's look at the intuitive solution we have. So yeah. So this is the Pythonic solution which I have tried to figure out. So what we will do is we like write a function like say the jackpot of L, which actually takes an input where then L is the number of gold coins which we have to say get out. So what we are doing is first we are creating a DP array of L plus 2. L plus 2, that's because to pouring of like for like we need to maintain for even 0 and 1. So we have to maintain L plus 2 sized array so that we can avoid this yeah, we can avoid this overfitting or something like that over this edge cases, some sense. So now what we'll do is for I in range of 2 comma L, what we will be doing is we will do one update. This is the basic update, which is dp of I plus 1 is equal to min of dpi plus 1, which is the current one, or 1 plus dp of dp of I. So basically, this is the first case, literally. We will be getting, if you place one copper coin, then you will get one gold coin out. So this is the first case which we had with us. So that's what we are doing it. We are checking if suppose the current is the minimum or 1 plus the previous is going to be the minimum. So that's what we are checking here. Next, we will go to the now let's go to the second, these two conditions literally. So if we place 4 copper coins inside, then how many coins, and these two basically they are almost the similar conditions. Basically, we can club them up because that's how we can do. So for j in range of 2 into I, why is it 2 into I is because if I have say somehow my dp of I is basically 5, then the multiples of I, or say dp of 1, dp of 5 is equals to say some x or 10. That's what my value is. Now the multiples of 5, basically 10, 12, 10, 15, 20, all will require only plus 2 coins to be spent, because they all been remembered literally. So that's what I can think of. If I have dp of say some imagine some dp of 5 is equal to 10. So now my dp of say 10 will be, it's just 12. Again, dp of suppose say 15 will be only 14. So something like that we can think of. So that's what we are doing here for j in range of 2 into I comma L plus 1, which is in total, and we are skipping I. So we are just having multiples of I. What we are like updating is dp of j equals to min of dp of j, the original, or dp of I plus 4 plus 2 into this j floor division I minus 1. So this is the multiple, like, say, as we do not want to again and again, like, say, add 2 to this, we can multiply 2 into that, say the factor literally. So that's what the whole problem is about. So then we actually print the last value, like dp of L. So that's what it will store. So let me check if suppose any doubts are there. I believe there are, yeah. So believe this problem is straightforward. There is nothing. It's the basic dynamic programming problem where we have some 3 cases and we have to somehow check for all the 3 cases and then get and the complexity of the code should be maximum of n square. So that's how the constraints are also decided. So believe if suppose there is no doubt, I'll move to the next like week 11 say explanation. So yeah. So
yes, Sanat. So after week 11, also discuss the week 12. Okay. So
okay, sure. Yeah, I'll discuss the week 12 programming question too. So yeah. So the problem is like as Dashara is approaching, you're so excited as there will be a lot of sweets and savories cooked in your house, but you have some rules which should be followed to eat the sweets, else you cannot eat them. So let's see what are the rules. So imagine all the sweets are arranged in a line. Let the type of the ith sweet from left is AI. So it's something like we have A1, A2, A3, and A1 is like type 1, A2 is type 2, and so on. So what can we do is select I and j such that 0 less than or equal to I less than j less than n, which is like, this is like we can select any 2 sweets such that AI is equals to AJ. So that's what we can do, and remove AI to AJ every sweets which are between AI to AJ. That's what the two of, we can eat, not remove exactly, we can eat the as it's in the say data structures point of view, it is remove, but else we can eat all the sweets between AI to AJ. This is what the question, and decrease so that the array of the size actually decreases from j say n to j minus I plus 1. So n minus j minus I plus 1 will be the new length of the array. So what we have to find here is we have to find somehow the maximum number of sweets that will be left, like, that can, that's so that I can I mean the maximum number of sweets that I can eat in some sense. So that's what I have to find here. So let me go through some sample cases here. So now let me take this array 1, 2, 2, 3, 1, 2, 2, 3, 3. So here I find that this 2 and this 2, if I remove basically, that they both are same, like, a, basically if I have 0 index, 0, 1, 2, 3, 4, I could find that I equal to 1 and j equal to 2, where ai equals to aj. So in this sense, if I remove these two, then I can see that 1, 3, will be the, because I lead these 2, 2. Now let me select again 3, 3, and again like I equal to 1, j equal to 2, like I'll be just left with 1. So on a total, I ate four sweets. So that's going to be my answer. Now here, if I see this, like it's again when I select, say I equals to 1 and j equals 3. Here I choose I equal to 0 and j equals 2. I ate all these 3 sweets literally. So in some sense 1, 2, 1. So I'll be left only with 2. So I can eat only 3 sweets in total. So this is like, again, you can check with this test cases too. I can like say have this 5 and 5 and I can remove all these stuffs. So it will be like, 1, 2, 3, 4 and 5, 6. So that's the answer here. 6 is the total number of sweets, maximum number of sweets I can eat. So this is also a dynamic programming problem. You can think of any good solution to solve this. So let me also explain the week 12 programming assignment. So this actually goes like this. So Janani is an undergrad student studying in a university. There are n working days in the college, and each of these days Janani might have some classes at the university. So there are m working hours during each day, and each lesson at the university lasts exactly for 1 hour. So what is happening is, so in this university, there are only m working days, and in each days, only 1 hour we can think of. So basically 1 period or something. So it's exactly 1 hour. If someday Janani's first lesson is during the ith hour and the last session is during the jth hour, then she spends exactly j minus I plus 1 hours in the university. So this is intuitive. Why it is so? Because ith hour and jth hour, so she have to sit from ith hour to like height class to the jth class. So in the intermediate, she might not have classes, but still she is required to sit to attend the jth hour class in the university during the day. If there are no lessons during some days, then Janani stays at home and therefore spends 0 hours at the university. So this is clear. So if there is no, say, any type of like say sessions, so she is not going to come to the university. Janani doesn't like to spend a lot of time at the university, so she has to skip some lessons. She cannot skip more than k lessons during the week. So this is the constraint we have. So she can maximum skip k lessons in the week. After deciding which lessons she should skip and which she should attend, every day Janani will enter the university right before the start, and the start of the first lesson she does not skip, and leave it after the end of the last session she decides to attend. So that's what. So she only she gets the what she plans is she comes in the ith hour exactly when it starts, and jth hour after that she actually goes off. But she is say constrained to only attend the k lessons in a week. So what we have to find is we have to find the minimum number of hours she can spend in the university, so that like all the constraints are satisfied. So we have some constraints here, n comma m comma k, where n and m are less than 250 and k is less like again less than or equal to 250. Suppose we would take this example here, 251. So 2 is the number of days. And m is the number of say working hours during each day. So here we have 1, 2, 3, 4, 5. And 1 is the maximum number of classes she can skip. So she cannot skip more than 1 class. So if you see that here, if suppose if I can actually come in the first say hour here and then here basically. So in the first exam, Janani can skip any 2 lessons during the first day. So she can skip any 2 lessons, right? She can come only 1 class and she can like skip the other one. So and the so in the next thing she have to attend everything. So in some sense she have to sit for again another 4 hours here. So 4 plus 1 will be equals to 5. So because the first hour is here and the last hour is here, so she have to attend all. So it's like 4 plus 1 is equals to 5. And here in this case, she have to attend all the classes because like K is 0 here basically. So she have to attend all the classes. So basically it's the number of ones here in the, say in the whole thing. So 1, 2, 3, 4, 5, 6, 7, 8. So all the, say classes she have to attend literally. So this is the problem statement. I believe it is understandable. If not, can someone like, say any doubts?
Can you scroll up, Sana?
Yeah. Is it
In
visible?
the test case,
Yeah,
test
test
case.
case. Yeah.
Yeah. So in sample 2, that means
So in 1, if we said so till the last one, so 1, 2, 3, 4, this should be attended basically because she can't skip the intermediate classes. And here one again. So here again 4 classes she have to sit. So she'll spend an overall 8 hours.
Total 8 hours will be required. Okay, fine.
Yeah.
Yeah, anyone have any query in this problem to understand?
Yeah. So let me take the silence.
Okay. Now we can move to the big 10 problem assignment 2. Yeah. Yes, Arnath, you there?
Let me stop sharing.
Sorry, Puspin.
Yes, Atul.
Yeah, okay. Yeah, go ahead.
Let me share my screen. Okay, so I'm guessing everyone is able to see my screen. So the week 10 assignment two is the problem statement goes something like this. Alice is about to embark on a journey into the wonderland. Before she does that, she wants to pack foods with adequate nutritional value. And she wants to ensure that she carries the minimum number of items on her journey. Help her figure out the minimum number of items she can carry. Alice has infinite supply of each item. The input format is like there are two safe space separated integers n and m. N is the number of items to choose from. M is the nutritional value of all the items you can carry. The next line contains the n space separated integers, giving the nutritional value of each of the items. Just to go over the example input, you have 4 and 10, where it means that 4 is the number of items you can choose from. 10 is the nutritional value she can carry. And if we notice that the nutritional value for the output is 2, because the third item can be taken, two counts of this third item can be taken, which would amount to the sum of 10. Any other combination would give you more number of items. I think the problem statement is pretty straightforward, and it's not very much trouble. The solution is based off dynamic programming. All you have to do is like you check the value, meaning it's a loop on the value itself, and for each value you have another inner loop where it goes through all the items for that value. And what you do is that you check whether the item's value, meaning the nutritional value, is less than the ith value of the at that particular nutritional value, whether it's less than the uh, value that you're actually browsing. The next line just checks the value of that minus the current value, and then it adds 1 if it follows this, it's satisfies this condition where it's not, the result is not equal to int underscore max, and this the result itself for that particular nutritional value is less than the count that you have already currently have on that particular table value, at that particular nutritional value. The last point is that if it is not possible, meaning the value that you're looking for doesn't cannot be accumulated, in that case you return -1, else the last value, which is your nutrition value, in this case 10, 10, you return the answer at the last index of that value. That's pretty much straightforward. Is there any questions on this statement, meaning problem week 10? So this meaning, just to reiterate, the solution itself is browsing through all the possible values from 1 to 10, and at each nutritional value, it is accounting for what is the minimum count at that particular nutritional value. So it's building up from 0 to 1, no, 1 to 10. Okay, I'll take no response. There's no questions. Let's move to week 11 programming assignment. Okay, so the week 11 assignment is Shrek has started on a journey to rescue the princess from evil monster that has trapped her in a dungeon. The road is long and he needs to plan his journey so that he makes the minimum stops in the villages along the way. At each village he chooses to stop. He gathers resources that would help him in his journey to reach the next village. Help Shrek find out the minimum number of villages he will have to stop at for replenishing the resources to make his journey to the dungeon possible. The input format is the first line contains the number of villages along the road leading to the dungeon. The next line contains n space separated integers, giving the maximum number of resources that can be accumulated at that village. So representing the maximum number of villages he can travel to without stopping based on the resources he has collected at the village. What you have to do is print the minimum number of villages from where Shrek would have to collect resources to reach the dungeon, represented by the last value in the array. So this value is basically a placeholder, not necessarily a value itself. So at the first village, Shrek can accumulate resources to reach the next two villages, which is second and third village. On reaching the third village, because if he chooses one, then he can only move to the next village, but he has the option to collect more resources at the third village. So if you reach the third village, then you have the option of then Shrek would accumulate for the resource for the next village, and at that point he can collect all the remaining resources which would help him reach the last location in this. Hence the answer is 3. So basically what you're trying to figure out is that minimum number of stops on his way to the journey. That's straightforward. It's a dynamic problem and shouldn't be meaning, yeah, it can be tricky. But yeah, any questions on this? I'll take the chat and no voice as no. Good. I think I explained very good. Let's move to programming assignment 2 for week 12. So week 12 programming assignment 2 goes something like this. The statement goes something like this. Human mind has always been a source of awe for its creativity. Lying is also a creative process, but lying is often grounded in reality. You have stumbled upon the code to unlock the secrets of mind. However, the code is distorted because the individual who gave you the code wants you to fail in that pursuit. Later, you found another code claiming to be authentic for opening that secret, and this code is entirely different from the one you procured earlier, at least at first glance. Now, with the knowledge that lying is grounded in reality, you devise a method to figure out the code based on this assumption. But before getting to the part of the potential candidate for valid code, you need to figure out the length of the code. So the input is the first line contains the sequence of characters for the first code. The second line contains the character sequence for the second code. So what you have here is this AB, first sequence is ACADB. The second sequence is CBDA. Now, the expression goes something like, if given the output possible, there are possible codes. These are the possible three codes, meaning CA, CD, and CB. Now, based on, because now how is that the potential candidates? So we said that the codes are distorted, but the idea behind is here that some aspects of the code which are actually true are still part of that code. It's like original message has been drowned in noise, with noise. So what you're trying to figure out is removing the noise itself from that code. So what you figure out is the common values which occur in both the codes. So hence the possible candidates for this code is like CA, CB, or CDN, and the length of all of these codes is 2. Hence the answer. So these are the 2 public test cases here. If you notice that H, F, and G are the characters that come in this code, second code as well. Now you have to ensure that the sequence of the character is also matters. Actually, it's not randomly you can select which character is. It's not like presence or absence of a particular character. It's like the sequence of the characters should be similar in both cases. Okay. Any questions on this?
So Pushpin, in short, yes. Actually what we are trying to find out here is longest common subsequence. Correct?
Yes.
Okay, in 2 strings, we are just finding out the longest common.
Yes.
Okay.
Yeah, I hope it helps. Any questions? Okay,
there is no questions. Now all the things are done. Now we will conduct one more sessions after the week 12, and we will just cover the solution of week 11 and week 12, both these credit programming assignment in that session. Okay, if anyone have any query. Okay, so if you have any query, you can also post on the forum. Then we will check the query on the forum, and we will just reply it on the query. Okay, thanks everyone. We will meet you in the next session. Thanks.
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 Bye bye.